Hello, mentors. Welcome to the area challenge. Look at these all shapes. All have the same area except a few. Can you find out which ones? Do not use a ruler. Which strategies did you use? And then we have a bonus about what's the meaning of these letters. Okay, so yeah, that's the challenge. It's a team challenge, so all students in your table will collaborate. Of course, they can, be in pairs and make small discoveries, discuss if they have conflicting results when comparing, and finally say what's the solution. So it's important not to use a ruler because otherwise it's still, of course, math, but it becomes just different. We want more conceptual understanding of areas, meaning area preservation or how you can fit a shape into another to conclude that they have more or less area, etc., overlaps, all these conceptual things. So here's the solution. Almost all shapes are equal. So let me go here. A, B, D, E, F, and G all have the same area, and C is larger than each of these, and H is smaller than each of these. So there's just like three categories of size: large, medium, and small. However, they're pretty close. So eyeballing is not reliable. So let's talk about strategies that students could use. So just looking is tricky and unreliable, but it's a first approach. It can be a first way to get the intuition just by looking without any markings, tracing. Let students know that they actually need to go beyond this method. So they cannot just guess by looking. Another strategy is copying shapes. So they can get a paper or the notebook and literally trace and copy the shapes, one or two, in strategic ways so that they can compare and overlap, things like that. They can also do foldings, so they'll get these manipulatives, so they can rotate, fold in any ways they like to start discovering properties between the shapes. They can imagine cutting shapes, marking parts of the shapes with pencil, like a point or line segments, just to get more information. And finally, overlapping shapes and reason about the difference. So that's a very important trend. After the relative comparisons, if you have time, they could compare lengths. It's kind of inventing a natural ruler. So they replicate the figures, trace, and compares just the sides of the shapes to get kind of a unit of measurement. For example, this could be a 1 or a 2. And then if this is a 2, maybe this is a 3, and so on. And then they can use the areas formulas for rectangles, triangles, or these shapes just to check that what they did is correct. However, have students do this only after they use these type of strategies. So it's important that we leave this only to the end of the activity if they have time. So if you go to the teaching guide and other videos, you'll see how we can compare shapes. Some are easier than others. In particular, I think this is one of the hardest one, how to get E to compare to the rest. So let's see where E is in this graph. So how to make sense of E and get it equal to the rest of this family. So actually, nice ways to compare it to G. Take a look quickly. But it's not clear at all at the beginning because look, if I move E, sorry, if I move E, doesn't really fit, so it's not clear. The trick is to generate lots of copies of G, lots of copies of E, and then you'll get the same rectangle and the same number of copies here and here. Okay, so hopefully your students have a lot of fun. Remember that they don't have to classify all shapes. So even if they make just partial progress and they classify maybe a 5 or 6 of the shape, that's good enough to go to the break in the meeting. But what's important is that they are using intuition and good conceptual understanding of areas. That's what you're looking for instead of just computation. So a lot of communication, a lot of ideas or moves, geometric moves that show that students can understand areas and the properties about areas. Okay, see you in another video. Goodbye.